Hey, g'day, it's Prezzo. Back working on the Stuart Turner 10H engine today, and in the previous episode I got this base casting machined and I did most of the machining on this engine frame here. I've temporarily bolted those two parts together and I screwed everything down to this piece of wood so I can hold it easily in the vise. And what I need to do first is to clean up this slot. Now this part of the engine frame here is called the trunk guide. The crosshead would slide up and down inside the bore of the trunk guide, and that oval or slot there that you can see is so that you can assemble the piston rod to the crosshead and the connecting rod to the crosshead. And I'm just going to file this. I think in a full-size engine that slot would just be as cast. It would be cleaned up with files and grinders and so on, but I doubt very much whether that would be machined. So I'm just going to cosmetically make that look like a rounded end slot, and then we can move on. That cast iron is really super hard and is killing my file, so I think I'm going to get the Dremel out to do this. So I have got that where a 3/8 inch drill bit will now slide down the full length of that slot there. And you're probably thinking, should have used a slot drill or an end mill, and yeah, could have done that. But I like the idea of being able to hand file something like that and to get it look accurate, but at the same time it should have that look as if it is a full-size casting. Now unfortunately, when I went to deburr these edges and round them over, the one at the top here is chilled and it's very hard, and it was damaging my needle file. I have got one of these diamond needle files and I've been able to get in there and actually clean that edge up. I want to get more of a radius on that at a later stage, but for now it's good enough to go on with the rest of the machining. I need to go ahead at this point and I've got to drill and ream for the crankshaft, and I've only machined off one face of each half of the bearing brass, so the other end is still over length and unmachined. I find it's always a good plan to leave your stock over length if you can, and that gives you some wiggle room if something's gone wrong, and there's no need to have this machine exactly the length at this stage. Now this fixture that's in the vise at the moment is sitting up against the vise stop, and it's sitting on two 12mm dowel pins, but only because I don't have any short parallels. That puts it down far enough in the vise so I can clamp the bearing brass in there. And what I can do now is centre fine between these two faces of the pocket, and that will put the spindle of the mill directly over what will be the centre of the crankshaft. And then I can loosen the vise, put these in, reposition it against the vise stop, and go ahead and drill and ream. I've got to machine the bearings now. They've got to finish at 19-30 seconds, and I'm using the same fixture that I used to drill and ream. I've got it sitting on a thin parallel, so I'm going to skim the top, work out the offset, and then I can finish them to length. There's about 3mm to come off. I'll go and measure that and work out the difference. That's done now, but we got a couple of lathe operations to go, and then we'll drill the holes in the top. Second to last step on these bearings now is to machine a boss on both sides, and that will reduce the overall width of this flat surface on top. So I've made a little mandrel here, and we can just simply slip them onto that and then hold it in place with an N5 screw, and we can flip it round between ends. So that secures that onto the mandrel. And I'm using an aluminium insert here because once again it's got a nice radius on the corner there. And I've already got the DRO set up so I can just machine in the two widths that are required from both ends of this bearing. Alright, I've already done the other one. All we need to do now is put some holes in the top for the studs and a central hole for the oiler. The last job in these little bearings is to drill the 3 holes in the top face there. 2 outer ones are 7BA for the studs that hold them down, and the middle one is for an oiler, so that's 5BA. Now I did this one yesterday and I got this one set up in the vise ready to go. And when I did this one yesterday, I set up the 3 points in touch DRO. Now I've turned the tablet off overnight. Let's just see if the settings are still there and we just continue on. So we'll just wake up the tablet. Right, so let's start touch DRO. Ah, there it is. So we're still set at 0, 0. Here's our 3 points. Let's have a look at the actual 3 points on the screen here. So still set up over the middle one, and then I've only got to offset either side. So that's one of the things I like about touch DRO is you can do these sort of work offsets here, set the points, and they're retained in the memory for as long as you need them. You can delete them later if you want to, but I can just go side to side now and get those 3 points. So the setup is just having this top surface here resting on these 2 pieces of brass plate here. I've got a piece of copper between the moving jaw and the end of the bearing, and I've not over tightened the vise. It's very easy to crush these bearings if you really crank on the vise there. I've got a vise stop set up so that when I did the one yesterday I just had to pop this new one in and I don't have to move anything with the offsets. Yeah, I know it's noisy. Okay, that's our 2 bearings done. So this is the crankshaft we need to do next. Now this, I believe, is either malleable iron or cast iron. Now I machined one of these for Stuart Turner number 8, and it didn't machine like steel, and it didn't appear to be cast iron either. So the chips come off in sort of short-ish spirals, but certainly nothing like steel. All the diameters are finished at 9/32, and needs to be 5/16 of an inch between the crank throws here. So what I'll do is I'm going to rough machine this all over, and then we'll set it up between centers to finish off the main shaft. And then I'm going to try offsetting it in a square collet block to machine this piece here. So yeah, they're complex things to machine, but you just got to take it nice and slow and just be aware at all times of where the bits are spinning. You'll see what I mean as we go along. I'm just going to center drill this end, and then I'll put a tailstock center in there to give it some support, and then rough machine this diameter. Then I'll turn it around, do the same thing at the other end. You can sort of see by the way the chips form on this that it's probably not cast iron, but certainly not steel either. And that's why I think it's just malleable iron, which is actually really nice to machine. That's still very much oversized, but it's fully turned the outer surface there, so I'll flip it around, do the other end. Alright, that's cleaned up both ends of the crankshaft. It's way oversized, but I've got a cylindrical surface both ends. And what I need to do now is set this up between centers to do the finish turning on these diameters here. Now that's a problem because you need to put tailstock pressure on the crankshaft and it will try to spring closed at this point here. So what I'm going to do is I'm going to file out the areas between the crank webs just enough so I can fit a jack in there. I'll go and do it and I'll come back and show you. Okay, I hope this is clear. What I've done there is I've filed between the two crank webs across that space there. So now I've got a parallel opening, or roughly parallel, still undersized, but what I can do now is I can fit a nut and a bolt between those two surfaces and spread the nut and bolt apart, and that sort of gives support between the two ends of the crankshaft. So there is the nut and bolt. It's a 2BA. It's very, very small, but will do the job. So let me get it assembled and I'll show you. Okay, there it is there. Now I don't have a lot of torque on the nut and the bolt. It's just enough to stay in place. And if I was to over tighten that, it would actually do the opposite to what we are trying to prevent. It would actually spread this area apart instead of collapsing it. But I'll get it set up between centers now. We'll have a look. Well, there it is. Now this is the best I can do at this end. I don't have a small catch plate for this lathe, and I've only got these two driving dogs, but that will work. So we can go ahead now and machine this end of the crankshaft to size, flip it end for end, do the same thing, and the little jacking screw is going to do its job and prevent the two crank webs from collapsing together. Now I've only got a moderate amount of tailstock pressure on that, but that's enough. So I'll go ahead now and get this end machined. I need to get a dimension across the crank webs here, and I'm just roughing it out at this stage, and I'll finish this with an aluminium insert, a carbide insert, because it's got a nice uniform nose radius, and that'll be just for the junction between the crank shaft and the web, so we get a sort of a nice radius in that corner. Just taking this out so I can measure it. It's got to finish at 5/8 of an inch, or 0.625, and we're still way oversized, so I'm just going to keep nibbling away at this face here. When I get it close, I'll take it out and measure it again and work out what the last pass needs to be. And it doesn't really matter which web we take that off, because the center hasn't been machined yet, and it still has a fair way to go to clean up the inside. Let's put a chamfer on there, and then this will come out. We can offset it to do the crank pin. Okay, let me see if I can explain this clearly and concisely. It's not easy. Alright, so what I'm trying to do here is machine the crank pin. So I need the axis of the crank pin to be concentric with the axis of the lathe, and that means offsetting the main crankshaft by the actual throw, which is 3/8 of an inch. So what I've done is I've put the crankshaft in a square collet block, and I've aligned one face of the crank web so it's parallel to one of the faces of the square collet block. Then I put the whole thing in the 4-jaw chuck, and I set the crankshaft to run true. At that point I put a digital angle gauge on the square collet block and I set it to 0, and then I offset the square collet block by the actual throw of 3/8 of an inch. So I'll see if I can show you. So what I've got is I've got square club lock set to 0 degrees now. We'll remove that. Now I'm going to move the dial indicator out by 3/4 of an inch. Now I said the throw was 3/8, but you'll see why it has to be 3/4. So we'll do that. Okay, that's it there. And now when I spin the square collar block over 180 degrees, it should read 0 on the dial indicator. Near enough. So I think I've got that set right. So what we'll do now is I'll just spin this under power and you can see what it looks like. So you can see the crank pin is more or less running concentric with the axis of the lathe. So I'll get in there and I'll machine the crank pin to almost its full diameter, and then I'll try to clean up the inside of the crank webs to their finished dimension, and at the same time try and get the crank webs the same thickness. I had a bit of a change of heart here. I decided to clean up the inside of the web first. So I've got a tool here with a lot of side clearance, and I'm just going down the inside of the web there, and that one is actually to size now, so I can measure the offset between the crank webs and do the other one. Scary thing here is that you can't actually see what you're doing. You can't see the chip forming. You just got to listen and maybe stop the lathe and have a look at what's happening on the side face here. I'll just measure in here and see what I've got. About 1/2 millimeter to go. Okay, that's the size now between the crank webs. I'll clean up the actual journal itself, the crank pin. I've just been doing a lot of this off camera. It's super scary. If this slips or something catches, it's just going to mangle this, so I'm really having to concentrate. I find that this inverted parting tool seems to be doing the best job, and I'm still about 1 millimeter oversize on this part, so I'm just going to go along slowly, taking very, very light cuts and just trying to listen. It's about all you can do. You just listen to the cut. If you hear something unusual, you've got to stop and figure it out. Okay, I'm going to measure that now, and I think I've got about probably 3/4 of a millimeter to go, but I'm going to do the rest off camera. Sorry, but I've just really got to concentrate here. It's super scary. It could all go badly wrong. I'll bring it back when I'm done. Alright, that was my finished cut there now, and I seem to have got through that without a disaster, but it was a bit nerve-wracking. So I'm going to clean that up with some emery, and the shaft itself is still over length. I'll machine it back to its finished length later, but for now I think that part is done. Alright, done. Well, there it is, and if you're wondering what's happening with the finish on the side of the crank webs there, I'm leaving it like that. I want this to look like a forged crankshaft. If that were machined all over, some people would look at it and say, well, that's just been fabricated from stock material. But you look at that and you say, no, that's been forged. Just getting set up to machine the flywheel for the engine, and one of the hard things to do with a flywheel like this is to get the section which is sort of unmachined to run true to the rest of the flywheel. So what I've done is I've set this up in a 4-jaw chuck, and I've dialed it in as close as I can just by eye, And then I got a pin chuck and mounted it in a tool holder, and I've got a piece of stainless steel TIG wire gripped in the pin chuck, and I've sharpened the other end to a point. Now what that allows you to do is to dial in the casting the rest of the way. Now the conventional dial indicator is a bit useless on rough casting, but this allows you to get it really close. And I can hear the wire just scratching around the inside of that rim there. So I'll just shut up and you might be able to hear it too. That's touching nearly all the way around. Wait till we come in closer. So this is a really old school low-tech solution for doing castings and getting them running as accurately as possible. So what I'll do here is I'll be able to machine the rim of the flywheel, both edges of the rim, center boss. I'll be able to drill and bore for the crankshaft, and then all I have to do is turn it around and do the other side, and that's less critical. But this is the bit that we're going to leave unmachined just in here, so we really want that to be running true. That's all it is. Really simple. I think the key with this is to take it easy, don't get greedy, just take very light cuts while you've still got a rough surface on the outside there. The grip in the center is a bit precarious, so if it was to catch, it'll pull the wheel out of alignment and then you're going to lose all your concentricity. I've already had a move on me once, had to tap it back in again, so I'm just taking it very lightly at this stage. The face of that rim there cleaned up in two very light passes, so we must have got it close. Not real happy about the inside of that rim there. I need to grind up a special tool to get in there and run it at very low speed. There's a little bit of chatter, and I'm pretty sure I can get that cleaned up. I'll take that. Okay, I've turned the wheel over and I've dialed this in as best as I can get in this 4-jaw chuck, and I've got some copper protecting the rim of the wheel here. But when I say as best I can, watch the dial as I rotate this. And you see the needle is moving as if the outside of the wheel isn't round. And what's happening here is we've got a 4-jaw chuck, we've got a 6-spoked wheel, and the pressure of the chuck is deforming the rim of the wheel. But I'm not machining the rim, I'm only machining the edge of the rim, this surface here, and the boss in the center here. So I'm not too bothered, and I've already got the bore concentric with the outside of the wheel, so everything should be fine. Now, to get the 1/2 inch width, I'm going to take more material off this, and I'm going to lose that little edge on the cast wheel there. But I'll put that back in again, and then I'll sandblast the center of the wheel when we're done. Now, I saw Joe Piezinski do this, and he was able to replicate that cast look by doing that. So I think that's where we're going with this. Well, that's the correct width, and I did lose that feature on the inside of the wheel there. I'm just going to have to fake that. That takes care of everything except the inside of this rim here, and I want to turn around the other side later on and clean up the same feature because it had a bit of chatter and it didn't look very nice, so I'll work on that and then the flywheel's done. Oh, forgot. I'm going to put a keyway in this, and I'm going to try and hold it onto the crankshaft using a tapered gib key rather than the traditional sort of grub screw through the side of the boss there. I know that's easy for a model, but it's not what would have been used on a full-sized engine, so I want to try and do that just for fun. So that's coming up. Well, I've done a trial assembly of all the parts that I've made so far, and I'm very happy to report that when I bolted down these bearings and had the crankshaft installed, it all turns really nicely. Now, I was a bit concerned that the two ends of the crankshaft would have got out of alignment because of the way I turned that between centers. But if that was the case, that crankshaft wouldn't turn at all. So that part of it's turned out really well. The flywheel is also a really nice running fit, and it runs true on the crankshaft. And the next step, of course, would be to fix that to the crankshaft. And typically, or on the drawings, it's shown as a grub screw through this section of the boss here, and it clamps down onto the crankshaft end. Now, I'm not overly happy about that method. It's sort of not full-size practice to do it that way. The flywheel would always be keyed to the crankshaft. So what I've done is I've made up sort of a prototype slotting tool, and this was done on the Diva grinder here, and this was ground from an old broken high-speed steel end mill, and it sort of works, but it's too short. I just didn't have enough material there to get a decent shank on it. So what I've done is I've ordered some new high-speed steel blanks, 6mm diameter and 8, and they're long enough to be able to get a decent length tool out of that. So I'll grind up a new one, and then we'll have a go at putting a tapered keyway in the flywheel, and then the keyway in the crankshaft I can just do with a normal end mill. And then we'll make up a tapered gib head key to go on this side of the crankshaft here. Now, in the next episode, I'm going to have a go at doing this connecting rod. Now, this is what is supplied in the kit, and I think it's just a brass stamping. Now, I'm not going to use this part. It's not full-size practice to make connecting rods out of brass. They would be made of wrought iron or steel, and this section here, the big end, would have a bronze bush in it. So when I made the connecting rod for the Stuart Turner number 8 engine, I made the top part out of steel, and that's because I screwed this part up. When I was machining that, I didn't look at the drawings correctly, so I was sort of committed to making a new one anyway, so I made it from steel. And I made the lower section out of bronze or brass, whatever it was at the time. So I'm going to do the same here, and I've got some scrap bronze here. Now there's enough material there to make the two halves of the bearing, and I'll just make the top section out of steel. Now the crosshead is also coming up, and that's just again probably some sort of brass stamping, and I think in this application that will be fine. And we'll do the piston rod, which is pretty straightforward. Now, In the next video you see coming out, it won't be about this engine, it's about an accessory that I bought for my milling machine, and it integrates with touch DRO. So I'll show you that and then we'll get back onto this build here. So I'm just trying to break up the release of the video so we're not doing steam engines all the time. So join me for that one, and thanks for watching today. Appreciate your time. It's Prezzo. Cheers.